So in this first question, you could just calculate each of these together. But a really neat little trick that I want to show you is looking at different combinations of numbers and patterns with them. So for example, 80 times 3, you could also, that gives you 240. That is the same as 30 times 8. So it's very interesting there. This relationship, these are equal, because this is really 8 groups of 10 times 3. This is 3 groups of 10 times 8. Really, you can move that around. 8 groups of 10 times 3, 3 groups of 10 times 8. They're the same thing. Likewise, you're going to find that with 70 times 4 and 40 times 7. This one, 70 times 4, is really the same as 40 times 7. And then you're also going to find that a little bit later on. You're going to find that with 60 times 5 is the same as 50 times 6. So what you're going to find is that 80 times 3 take away 30 times 8. Those are actually the same thing, and they're gone. Then you're going to find that this one here, 70 times 4 and 40 times 7, they're the same, and they're gone. Then you're going to find this one and this one are the same, and they're gone. So really, all you're left with is 20 times 9, which is 180. So yes, you can find each one separately, but there's just a little trick to make it a little bit quicker, a little bit easier. So just something to think about. This next one here, 3 pencils and 2 markers is $1.30, and 2 pencils and 3 markers is $1.20. Now what I want you to think about is if you just put these all into kind of one big basket, put them all into one big basket, you will get 5 pens and 5 markers if I put these together. If I put them together, then this will equal $2.50. So what that tells me is if 5 pens and 5 markers is $2.50, if I just divide it by 5, and with equations, whatever you do to one thing, you can do to everything, what you're going to get is that 1 pen plus 1 marker is 50 cents. And then knowing that, that means that 7 pens and 7 markers must be 50 cents times 7, or $3.50. So kind of a really neat way of looking at the problem is to be thinking about it as one big group in one big bucket, and then thinking what 1 pen and 1 marker, it actually doesn't matter. You'll notice here, I didn't actually calculate the cost of a pen or the cost of a marker. I just know that together 1 pen and 1 marker is 50 cents. So then I know that together 7 pens and 7 markers must be $3.50. So again, kind of a cool question to look at. This one's a little bit more challenging. Divisible, I know some of you are asking me, what does the word divisible mean? It means that 32 and 36 go into or divide into 2016 with no remainders. So they are factors of 2016. So to find the next number that both of them goes into, we need to think in terms of multiples of 32 and 36. So one way of doing it is you could just list the multiples of 32 and keep going, and you could list the multiples of 72 and keep going. If you kept listing the multiples, you will find that the lowest common multiple will be 288. Another way to do it is to break down the numbers into factor trees. If you're in grade 6, you've done some work with that. So you're going to see that this is 32 is the same as 2 to the exponent of 5. 1, 2, 3, 4, 5. That's how I say 2 to the exponent of 5. And 36, if I broke that down, 36 is 3 squared times 2 squared. And so what you're going to find is that the lowest common multiple, based on these factor trees, the lowest common multiple will be that times that, or 32 times 9 or 288. Once you know what the lowest common multiple is, all you need to do is realize that if you know that 2016 works, then the next number that works will just be 288 more than 2016, 2,304. So this connects, if you're in grade 6, it connects a bit with some of the work that you've done with divisibility and factors and lowest common multiples, and it's related to those types of topics. If you're in grade 5, some of this might be new to you, but then here's an extension to look at, to explore, to challenge yourself. Okay, these questions are quite popular kinds of questions for problem solving. Some of you were a little confused by what it was asking. Basically what this means is that everywhere you see an A, it all equals the same number. So A could be 1, it could be 2, it could be 3, it could be 4. Digit means anything from 0 to 9. D are all the same, and then this will equal something that is SUM, so those are going to be different. So one thing that it tells you right away is A can't be 0. The other thing you have to think about is that we have 4 3-digit numbers, and they're going to equal a 3-digit number, and that's not very common. Usually when you add a bunch of 3-digit numbers, you're going to end up with a 4-digit number. So one way to sort of look at this question is to start with the letter A and realize that A has to either be 1 or it has to be 2. Why is that? Because 1, 1, 1, and 1 will equal 4, or 2, 2, 2, and 2 will equal 8. Remember, we have to create a 3-digit number. Why can't it be something else? Well, as soon as I make it 3, 3, 3, and 3, that's going to equal 12. Now it's not a 3-digit number, it's a 4-digit number. So the only possibilities are a 1 or a 2 for A. But the question asked you to come up with the greatest one. So because of that, we're going to examine all of the possibilities as if A were 2. So let's look at A being 2. So what are some things we could have? Well, we could have 2 and D could be 3. So let's have a look at that. Remember, all the A's and all the D's are the same. So when we look at that, we get 12, we carry that, we get 12, but plus the 1, we carry that, and then we get 9. Now, if we look at that answer, that means this would be the S, this would be the U, and this would be the M. But this can't be right because U can't be the same as D. Notice this, if my D is 3, my U can't also be 3, and M can't be the same as A. So that one can't be right. So then I'm going to say, okay, D wasn't 3. What else could I try? Well, let's try D as 4. Oops. So 4, 4, 4, 4, 4, 4, 4, and 4. So when I add this, I get 16, carry that, I get 16, but with the 1 I get 17. And when I look at that, I think, okay, yep, that's possible. So what do I do next? Well, let's try 5 then. So remember, I'm trying to come up with the greatest number. I guess the one that I skipped at the beginning, I could have done D equals 1. I didn't do D equals 1. I could have tried that one. So if you're wondering why didn't I try D equals 1, that's why. Why didn't I try D equals 2? Because A was 2, so D couldn't be 2. So let's try 5 now. So when I add this up, I get 20. I get 20. Now, because I had the 8 and I carried the 2, uh-oh, now I'm at a 4 digits here. That's going to be too big. And if 5 was too big, 6 will be too big, 7 will be too big, and so on. So that means this is the answer here. So again, the only one I didn't try, and I guess I should have tried, was 2, 1, 1. But remember, you're trying to get the greatest, so I guess I just started with a bigger number. So that was something that you could have thought of. All right, so let's moving on to the last question. Now, this is a very interesting one, and I think a lot of you were quite confused by this. When it says 80 1 by 1 by 1 cubes, that means we're creating something that has a volume of 80, okay? Then we have to think about how we could have a volume of 80. We could have dimensions of our rectangular solid could be 1 by 1 by 80. They could be 1 by 2 by 40. They could be 1 by 5 by 16. And then we can look at all different kinds of possibilities of what could happen. It could be 1 by 8 by 10. All of these will give me a volume of 80. What I can then do is I can examine the surface area of each one. And if I look at a rectangular prism, think about like, I don't know, a Kleenex box, for example. You've got a surface here, and there's actually two of those surfaces. You just don't really always see it. So the other surface would be that one. So that'll be, let's say if we call this our base, our height, and our depth, the red one will be the base times the height times 2. Then we have a surface that's like the bottom of our Kleenex box, but we'd have that on the top as well. So that one would be the depth times the base times 2. And then we have one more surface. We have the surface that would be the front of the Kleenex box, and then there'd also be a back, and that would be the depth times the height. And there are two of those. So that's how I'm going to get what's called my surface area. So you could look at all of the different possibilities for your rectangular solid and find all the surface areas, because it asks you to find the one with the smallest surface area. Now, if you start to do some more work with math, you're going to realize that the longer and skinnier something is, the more area it will have. The wider and fatter it will have, the least area it will have. So this kind of shape that's more cube will be, if these have an equal volume, to get an equal volume, this one needs to be really long and really skinny, which means there's a lot of surface. This one, to get the same volume, there's going to be less surface. So a cube will always give you the smallest surface area if you're looking at rectangular solids. So then what you have to think about is what dimensions would give me 80 that's as close as possible to a cube. And a cube means like 3 by 3 by 3, or 4 by 4 by 4, or 5 by 5 by 5. But you're going to realize that 5 by 5 by 5 is too big, and 4 by 4 by 4 is too small. So the one that's going to work with a volume of 80, that's going to be as close as possible to a cube, will be 4 by 4 by 5, which you could have found if you kept finding all of these possibilities. Now that we know it's 4 by 4 by 5, we can kind of use this formula down here and realize that our surfaces are going to be, so if we look at this part here, I'm going to use green, now it's getting messy. You have a side that's 4 by 4 times 2. You have a side that's 4 by 5 times 2, and then you actually have another side that's 4 by 5 by 2, because in this case your base and your height, let's say, are going to be the same. So you're going to have a 4 by 5 by 2, a 4 by 5 by 2, like the height, and then a 4 by 4. It asks you to find the face with the least area. A face just means one face. So this part here, actually I'll do it in black, this is considered one face. The one with the smallest area would be that one right there, which would be 4 by 4, which is 16. I know that's kind of a confusing question, but again, remember that the whole reason you've joined these is to get better with problem solving and to learn something new. And so hopefully these, even though a lot of you found this one really hard, hopefully you've learned something new with these questions.